Let us see how to use Dotty debug techniques to figure the cause of an issue. In the bad Scala file, we have the issue in question. The issue is that foo and bar compute essentially the same type, yet bar fails to compile. It fails to compile because the compiler thinks type parameter A appears in a contravariant position, while being declared covariant. Let us see why this issue happens. To see where spurious error happens, let us recompile with ydebug error flag. For every error encountered, this flag will force the compiler to print a stack trace pointing to where the error occurred. Let us now save the trace for further reference. Now let us go to the error site occurrence. The very last couple of frames typically define error reporting logic and aren't very interesting. So let us jump to the first frame that appears to be an actual program's business logic. We can see that the error occurs because variance conforms check failed. Let us now get more context as to where this code is executed from. To do so, let us go a bit shallower through the error trace to obtain the whole picture. One of the frames that may help us establish the context is the post-typer frame. Post-typer is one of the phases of the compiler, and having it in the stack trace indicates that the error occurred in that phase. This is a valuable piece of information to help us orient in the codebase and establish context. Let us see what is happening there. Apparently, post-typer tries to run some checks on a lambda. Which exactly lambda? Let us find out by debugging the variables involved. Upon inspection of the arguments, we understand that the check is run twice, and the lambdas in question are the types that appear in our issue. Let us now see what exactly checks are being run by this function. As you can see, the comment to that function indicates that its task is to check variances of a type lambda. Upon further inspection, check lambda is where the error actually happens. Now let us investigate what in the code triggered the error. The compiler errors because apparently variance conforms returned false. There is a variance computed by the compiler and a variance derived from the type parameter sign, and the two did not match. Let us test this theory by debugging the variables involved. Indeed, for the type parameter b, the variances match, but not for the type parameter a. In case of a, the compiler thinks variance should be -1, that is contravariant, whereas the declared variance is 1, that is covariant. Let us figure out why the compiler thinks the variance should be contravariant. To do so, we need to trace where the variance variable is set to -1. First, let us locate the variable definition. Next, let us instrument the variance variable with a tracer. This way, we will know where exactly this variable is set. Finally, let's print the tracer from the error site and save the trace to a separate view. Upon some exploration, we see that the variance setting happens close to the error site itself. The exact point where it is set is when the variance checker processes type bounds. We can test whether this theory is true by going a bit higher the stack to near the error site and preventing the processing to happen when we are dealing with type bounds. As you can see, the error goes away, thus confirming what we have just learned. We have just seen how the ability to navigate stack frames and debug variables can help you debug complex code bases. The concrete implementation shown is done via Sublime Text plugin system.